Now we're going to look at the basic ideas behind what makes matter matter. Most of you, again, should have some idea of what this is about, but this just formalizes some of the language. Matter is anything that has mass and takes up space, or basically has some kind of a volume that occupies the space that we live in. So I've given you a couple of these possible examples here. I'm going to kind of see whether or not you can figure out if these are matter or if they're not, right? If they are made of something that takes up space and if it, again, has mass to it. So let's take a look at paper. Paper, I think, is fairly obvious. You can hold paper in your hands. You can see that does have some volume, even though it's like really, really thin. Yeah, obviously it's there. Paper definitely matter. Air inside of a birthday balloon. All right. Well, again, a lot of times we tend not to think of air any kind of matter. It definitely takes up space, but does it have any mass? Well, yeah, you can definitely get the mass of a sample of air for sure. So yeah, that's also going to be an example of matter. Sunlight. Well, sunlight. Can you actually classify sunlight as matter? Turns out sunlight not so much, right? Because sunlight is not really something that you can hold, right? There's no real volume to it, and doesn't really have any mass either. Heat. What about heat? Does heat have is heat a form of matter? And it turns out no, it's not either, right? Because while heat, you might be able to say something can hold heat. That's really more of a conceptual idea of hold. I'm putting air quotes here with my fingers around the word hold. Yeah, that's kind of just vernacular colloquialism with this idea of holding. So heat definitely not a form of matter. Thoughts? Yeah, no. Right. So hopefully you kind of at least get some general sense of what this is. This is, again, just a little bit of review of what matter and mass is. And just to be sure, mass is a measure of the amount of matter that's inside of a substance. Some basic building blocks of matter. The next two slides sort of work in conjunction with each other. And these are all words and terms you've heard of, but the distinction sometimes ends up being a little blurry, so you're not really sure about this. So let's kind of break these down. First of all, the word element, again, is something you've heard of. An element is a pure substance that cannot be broken down into simpler, stable substances. All right, so the word element here, this is an example of we'll just say this is more of a category, right? So this is this idea. As humans, we have labeled certain things as elements, right? Certain substances as elements. They're categorized as elements. For example, we know that carbon is an element, right? Carbon is something that if we were to break it down, it wouldn't be carbon anymore. It wouldn't be that element any longer. Same thing with helium. And if either of them, again, you try to break either of them down, it no longer is an element. But an atom, on the other hand, right, an atom, this is the smallest unit of an element that maintains the chemical identity of that element. Meaning, this is the actual particle, this is the actual physical object that you can hold. Whereas the word element refers to like a category, right? So again, the concept versus the object. So category, that's the element, and atom is the physical object that, again, is there. You can touch it, you can feel it, you can hold it, you can pick it up, move it around. But again, in terms of knowing the difference, I'm going to use these two diagrams on the right to help show that. So if you look at this first diagram on the left, again, it's kind of got a label right here, carbon atoms, little circles. Each of these are individual atoms, and they're all sort of stuck and attached to each other, bonded to each other, if you will. And as you can see here, this is an example. This picture, anyway, this diagram shows an example of 40 atoms of the element carbon, right? There's only, these atoms all are of the same element, right? These all belong to the same category of substances, where if you try to break these down, it's no longer carbon. So these individual circles, these spheres, these are the atoms. There's about 40 of them there. On the other hand, on the right side, you have the balloon. In the balloon, you have about 9 atoms, right? These 9 little spheres here. Those represent the atoms of helium that's in there. But, right, there are two different elements that are shown between these two diagrams, right? Two different elements. You have the carbon, that's one element. You have the helium, which is the other element. Right? Keep that in mind while we bring that in, these other two. And you have compounds and molecules. Compound is a category of substances that can be broken down into its elements. It's composed of at least 2 different elements. So a compound, once again, this belongs to a category. This is how we categorize substances. Substances can either be an element or they can also be a compound. On the other hand, you have a molecule, very much related. A molecule is the smallest unit, right? This is the object, the actual particle. Right? It's a very poorly written object, the word object. The smallest unit, the smallest particle of a compound that retains all the properties. So these molecules All right, these are particles that are of certain compounds. Right? So compound, again, that's the category. The actual physical object that you can pick up and move around, that's a molecule. Also notice how the molecule is made up of multiple atoms. Right? So you have a couple of the individual atoms. Each of them might be their own element. You combine them together to make a molecule, and they all stick together, and that molecule represents a compound. All right, to kind of help, again, sort of solidify this, I know some of these terms get thrown around, and it's hard to distinguish between them. Let me show you this guy right here. All right, so this guy right here, I'm not sure how that drew that way, but you got this guy right here. This is an example of sucrose. All right, sucrose. So sucrose, you can see this word right here, sucrose, that's a compound. Right? This is a substance. This is a substance that we can categorize as a compound, right? Because we know that sucrose is made of a bunch of different elements, right? It's composed of several different elements. And because it's made of several different elements, it is a compound. Right? The elements happen to be hydrogen, oxygen, and carbon here. Right? You may have heard of this substance before. Same thing as table sugar, for what it's worth. In this diagram, though, we're showing one molecule, right? One specific molecule, one specific example of this object, right? So one object that you could pick up, move around, and so on and so forth. So this molecule has 45 atoms in it, right? And you can see that there's 12 atoms of carbon, 22 atoms of hydrogen, 11 atoms of oxygen, represented by the green, the blue, and the red. So there's a total of 45 individual tiny particles. Those all lump up together in this shape to make one molecule. And again, the distinction between compound and element here is that this is one example of a compound, right? This is categorized as a compound sucrose, but it's made of 3 different elements, right? 3 different elements. So again, it's more of a categorization rather than the actual object itself. If you want to, you can try this out. This is an analogy involving ice cream, looking at the different scoops and talking about servings and how we kind of categorize things and how we sort of label things. If this helps you, go for it, but I'm not going to spend any time on it unless you would like to go through it some other time. Comparison of terms here, again, this is putting all 4 of those ones we just saw a minute ago, atoms, compounds, elements, and molecules all together on this diagram. So we're saying here that benzene, we're just going to throw this word out, benzene is an example of a compound. This is a substance that has multiple elements in its composition, right? It's a compound made of more than one element. There are 3 molecules of benzene shown. So this is 1 molecule, 2 molecule, 3 molecule, right? So 3 objects shown. Molecules, again, are actual objects. And benzene, as a compound, contains 2 elements, one of which is this white element, one of which is black, which represents hydrogen and carbon, respectively. And so those 2 elements are shown in this one example right here. You see 2 different elements shown, 2 different elements shown all the way around. And one single molecule, one single unit of benzene contains 6 atoms of hydrogen and 6 atoms of carbon. Right? So that's the way that we can kind of break this down. Notice how the language does say a molecule of benzene, right? So one of these units contains 6 atoms of carbon. So 6 atoms of carbon, which are black here. And again, you could say 6 atoms of the element carbon. You can say that as well. But again, carbon is a classification, right? So it is a way that we categorize this substance, right? But we only have 1 carbon, right? There's only one element there that represents carbon, and then you have 6 of them that represent hydrogen. 2 different elements. Okay. Here's another example. I'm actually going to let you try this one out. See how you can apply those same 4 words together or in different sentences here. I've given you examples of substances here. You see that you have the red and the white, and you have the black and the white. There's a little bit of a key to explain it. So I want you to actually come up with a couple of sentences, or statements at least, on your own to test your ability to try and apply atom, try to apply compound, molecules, and elements. Okay. Now, when it comes to how we describe matter, that's also very important. This idea of a property, or that's not really new to you. Basically, a property is a description of something, and it defines the entire set of substances, so the entirety of whatever it is you're talking about. Extensive properties, these are properties that depend on the amount of matter that's present. Right now, let's go and break that word down. First of all, extensive, that as a prefix, hopefully you recognize, meaning outward, right? Meaning it's not really inward, right? It's kind of opposite, but basically saying that this is dependent on the actual sample, right, that you have in front of you. Things that might be included as an extensive property are volume. For example, a block of wood, right? A block of wood, one block of wood is going to have a different volume than another block of wood. So volume is an extensive property because it depends on the amount that you have in front of you. Whereas mass is the same thing, right? Mass, how much mass something has, that's also dependent on how much is literally in front of you that you can measure, right? On the other hand, you have intensive properties, right? Intensive properties. This is referring to properties that are inherent, that are innate, that are a part of the identity of your substance. These are properties that do not depend on the amount of matter present. So, for example, wood, right? Let's go back to that again. Wood. There's a lot of examples that you can look at in terms of intensive properties because wood has a certain color to it, right? It doesn't matter how big or small your sample of wood is, it's going to be that color. Now, again, you can sit here and make the arguments between like mahogany versus birch. Okay, fine, whatever. But in terms of that specific category of wood, you expect it to have the same color. You expect also, let's say, melting point, right? No matter how big or small your sample of ice is, it's going to melt at the same temperature, right? If I have a giant block of ice or if I have just the smallest shaving of ice, no matter how big or small the sample is, it will still melt at the same temperature. I want you to try this out. There are a couple of properties already presented on this slide. I want you to try applying two extensive, or at least identifying two possible extensive and two possible intensive properties about this block of wood that's not already on here. Right? So we've already talked about color. Okay, come up with something else. We've already talked about density, conductivity, melting point, so on and so forth. Before I move on, I do want to point out density. I think density is one that kind of throws us off a little bit. Remember, density is a ratio between mass and volume, right? So this is, again, not dependent on the amount of substance you have. No matter how big or small a sample is, right, that substance will still have the same density. If you have a giant iceberg versus a little ice cube in your drink, both of those still have a density that is identical, or at least reasonably close, that is less than, the water that it's in. So that's the idea of that density. No matter how big or small it is, right, it's still an intensive property because it does not matter on the size of your sample. Last little bit here, we'll talk about physical properties and physical changes. All right, so we talked about the word property already. It is a characteristic, right? So that's nothing new here. But we're talking about physical ones. Physical ones, and we'll compare this later on to chemical ones, so just hold that thought. But physical properties are properties that can be observed or measured without changing the composition. Right now, again, I kind of mentioned that word here and there. The word composition when it comes to chemistry is basically what it's made of. What are the individual tiny bits of atoms and elements that are in it? And so in this case, we're talking about physical properties, meaning these are properties that we don't have to change it to know what they are. Now, that's a little vague at first. We'll get to that later on and kind of make the distinguishing characteristics there. But examples here, I think. For example, copper. You guys have seen copper before, right? Copper that is used in various fittings and wire and so on and so forth. Copper has a red-orange tint, right? Can I make that observation about copper without changing it, without reacting with something? Absolutely, right? It is going to be that color, and all I had to do was look at it. Sure. All right. On another example right here, physical property of water is that it boils at 100 degrees Celsius. By the way, that's kind of worthwhile number to memorize if you don't know it already. Small detail for now. But water boiling at 100 degrees Celsius, that is a physical property. Does water boiling change the fact that water is made of hydrogens and oxygens? Not at all, right? It's a very specific water that's there. That's a compound. That does not get changed just because you boil it. Now, some of you might be thinking, okay, well, it gets changed to steam or vapor. Well, it is still water, right? So let's say we have a pot of boiling water. We have the steam that's rising up out of this, right? These substances, the steam that makes up this bit is the identical substance there. It's just in a slightly different form. Right, so these are physical properties. I didn't change the fact that it's water. It's still water. So I can make that a physical property. I can identify that as a physical property. Now, physical change is very similar. So change requires you to do something to a substance. But the key here, once again, is composition. Do physical changes cause a change in composition? Absolutely not. All right, so does it change what it's made of? For example, if I took a sheet of paper and ripped it in half, does it change what the paper is made of? Absolutely not. So that's an example of a physical change. Now let's talk about melting ice, right? So kind of in the same vein as what we did a minute ago, talking about water boiling. What about water melting? So if I have an ice cube, ice is made of water, right? And it melts. Well, it's still water, right? All these little particles of water that are inside of this cube now are just in a more liquidy form. Did it change what water actually is? Not at all. It just changes the form that it's in. Therefore, this is a physical change, right? So yes, this is going to be a little bit, take a little bit of practice. The key here, again, like I circled a couple times, is composition. In fact, let me highlight it just for you. There you go. All right, so you know that's going to be an important thing to keep in mind as you look at these. All right, now to wrap it up here, we're going to just take a look at a couple of states of matter. State of matter is basically, at least this way it's defined here, is one of the 4 distinct forms that matter can adopt, right? So I think you may find that to be a little bit big right now. We'll take a look at each example in just a moment here. And then, of course, you have with state of matter, you might also see the phrase change of state, where it's a physical change, where we're not changing what it is, changing it from one state of matter to another, usually because of temperature and pressure, also known as phase changes. So these words right here, change of state, phase change, the same thing, referring to changing the form that matter exists. Let's start with an easy example of a state of matter. Solid. Solid's a state of matter, right? We know that a definite volume, definite shape. So you can see these properties here. Hopefully, again, this is not really too new to you. Definitely review some of these terminologies. For example, the particles that make up a solid, right? These are the particles that make up whatever substance you're looking at, packed tightly, held together, so on and so forth. Got its properties. Liquid, same idea, right? It's got some definite, indefinite stuff there. Go and take a look at those, give that a quick review. Finally, gases, right? A third state of matter, which you might be familiar with, solid, liquid, gas. And then the fourth one, which we, might have been sort of questioning a minute ago, it's actually plasma. We're not going to work a lot with it. Just want to bring that up to your attention. If you really want to get into it and nerd out, really, there's actually upwards of 6, maybe even potentially a 7th type of state of matter. In this class, however, just these 4. No problemo. All right, that'll do it.